We want to continue talking about roots and radicals. Last time we looked at that principle of the square root. Remember that if no index is written, we have an index of 2. So the square root of a times the square root of a equals the square root of a times a. This tells us if the index are the same, we can multiply the radicands under the same root sign. And we already know that this equals a if a is greater than or equal to 0. Now I want you to notice that the index is 2 and we have 2 a's. Let's look at the next example. The fifth root of a times the fifth root of a, multiplying itself 5 times, equals the fifth root of 5 a's. So the index is 5. We have 5 a's in the radicand. This will equal a. Our cube root, the cube root of a times the cube root of a times the cube root of a equals the cube root of a multiplying itself 3 times. This equals a. So what do you think? If we have an index of 4 and under the radical sign 4 a's multiply itself, this will also equal a. Excuse me. Again, if a is greater than or equal to 0. Do you notice something here? Do you notice that I'm saying if a is greater than or equal to 0 only when my index is even? Well, that's not going to work, is it? Why do you think that is? We can find the root of an odd index even if the radicand is negative. Let's look at some examples here. The square root of 169. Did you know that was the square root of 13 times 13? This equals 13 because we have an index of 2 and there are 2 factors of 13. The index is 2, so we look for 2 equal factors. What about when the index is 3? Well, now we know that we're going to look for 3 equal factors. The cube root of 27 equals 3. Why don't you pause your video and try questions 2, 3, and 4. For question 2, we see that the cube root of 125 is equal to the cube root of 5 times 5 times 5. We have an index of 3. Let's try that again. An index of 3 and 3 equal factors. This equals 5. In question 3, the index is 4. 4 equal factors. This equals 2. In question 4, an index of 4, 4 equal factors. This equals 3. Did you get those? If that idea seems a little bit difficult, make sure you spend some time practicing those. Use the Pearson homework assignments where you can always look at a similar question. If you don't remember how to do that, please make an appointment to see me and ask how. All right, now we have the cube root of negative 27. I mentioned up here that I only said that A, the radicand, has to be greater than or equal to 0 if the index is even. So I'm looking for the cube root of -27. My index is odd. That means the radicand does not have to be greater than or equal to 0. Because we could write this as the cube root of -3 times itself 3 times. This equals -3. Notice that my answer is also less than 0. Pause your video, finish the next 3. For question 6, we have an index of 4. We have 4 factors of -3. This equals -3. Question 5, we have an index of 5, 5 factors of 2. This equals 2. And for question 7, an index of 6, 10 multiplies itself 6 times. This equals 10. Please go and practice this idea, because once we start simplifying radicals, once the questions become more complex, people forget what's happening here. So spend some time with it before moving on.